Hello students, as you all know that solutions are made up of solute and solvent, and these solutions on the basis of their particle size they are classified into three categories. They are true solutions, suspensions and colloids. As our today's topic is colloidal solutions, but before that we will study true solutions as well as suspensions. So, how you can define the true solutions? These are the homogeneous mixtures which have the solute particle which has particle size very small, or you can say in this particle size is less than 1 nanometer, right? That is 10 to the power minus 9 meter. And in case of suspensions are the heterogeneous mixtures which contain insoluble solute particles and in which particle size is more than 1000 nanometer, right? But there are some of the solutions where the particle size varies from 1 nanometer to 1000 nanometer, so that is the category of colloids, right? These are the colloidal solutions. So how we can define the colloidal solutions? These are the heterogeneous mixtures of solute and solvent in which particle size is in between 1 to 1000 nanometer. Now, as in the solution, there it is made up of solute and solvent. Solute is in less amount and solvent is in large amount. Similarly, your colloids, they are also made up of dispersed phase and dispersed medium. Now here, dispersed phase, the component which is present in less amount. It is acting similarly as a solute, but there is a different term, that is dispersed phase. And dispersed medium, the component which is present in large excess, that is known as dispersed medium, right? Now we have to classify the colloids. Classification of colloids, we will study the classification of colloid on three bases. So first of them is physical state of dispersed phase and dispersed medium. You all know that physical state, that may be solid, that may be liquid, or that may be gas. So first of all we will study on the basis of physical state of dispersed phase and dispersed medium. You can see the table in this dispersed phase. We have dispersed medium. Next is type of solution and then example. Now suppose we have dispersed phase that is in solid state. Now dispersed medium. As you took dispersed medium is in solid state, right? And you are adding dispersed phase that is also is in solid state. So you will get solid sol. And the example is colored glasses, your gemstones, alloys. All these are the examples of your solid sols. Now next you have dispersed medium that is in liquid state. अब आपने उसमें solid ऐड किया, then you will get sol. The most common example is paint, your cell fluid. Now in a cell there is a some liquid that is present, and there are some organs, they get organelles, they get embedded inside that, like mitochondria. So that is an example of sol, right? Next we have dispersed medium that is gas. In gas we have solids. So what type of colloidal solution you will get? That is aerosol, and the example is smoke, right? Now we have, in next cases, we have dispersed phase that is in liquid state. Now you have dispersed medium that is in solid state and your dispersed phase that is in liquid state. That is the example, that is a type of colloidal solution that comes under gel. And most common examples are butter, curd, jelly, because they are solid in appearance and they contain some liquid inside them. So they are the examples, right? Next we have liquid in liquid. Dispersed medium is in liquid state as well as dispersed phase that is also is in liquid state. The example is emulsion. Like we have milk, you have hair creams, all these are the examples of emulsions. Next we have dispersed medium that is in gaseous state and dispersed phase that is in liquid state, right? So example is aerosol. Type of colloidal solution is aerosol, right? And example here is fog, right? Next we have dispersed phase that is in gaseous state. Now your dispersed medium that is in solid state, or it may be in the liquid state. In liquid state we will discuss later. In solid state then you will again get solid sol, right? You are getting solid sol. Here the example is rubber, pumic stone. Your rubber, that is, you are able to press it because some of the air get entrapped inside it. As you are applying pressure, that air expel out, that's why you are able to press it, right? You have sponge, that is also solid in appearance, but you are able to press it because some air get entrapped inside it. So that are the solid soles. Now your dispersed medium, that is in liquid state, and your dispersed phase, that is in gaseous state. Here the type of colloidal solution is formed, and example over here is soda water. Now the next type of classification, second type of classification, is based on the interaction between dispersed phase and dispersed medium. Now what type of interactions they are going to possess? On the basis of that, we will get lyophobic, lyophilic, and lyophobic colloids. As from the word clear, philic means loving, and phobic means we have phobia, that means hating. So, in lyophilic colloidal solutions, how we can define them? The colloidal solutions in which the particles of the dispersed phase have a great affinity, have love for the particles of the dispersed medium. Then we can say that type of colloidal solutions are known as lyophilic colloids. Right now, these solutions, they are easily formed. They are very easy to form because they, here the particles of dispersed phase, they are loving to the particles of dispersed medium, as well as they are reversible in nature. Now they are reversible in nature. This is the very important characteristic. That means they get easily separated even by evaporation. Okay, so you can separate the particles by evaporation, right? Next is they are stable in nature. After that, these particles, these type of colloidal solutions, they do not show Tyndall effect. They can't they can't scatter the beam of light, right? Here they are not easily get precipitated because these particles have interaction with each other. So by adding an electrolyte, even in large quantity, you are not able to if you are not able to means coagulate them easily. If you are going to add the electrolyte in very large quantity, then they may get coagulate, right? So it is not easy to separate these two mediums. You can't separate the particles of dispersed phase and dispersed medium very easily. That means you can't means coagulate them very easily, right? uh, Next we have lyophobic colloids. Now lyophobic colloids, as from the word clear, phobia means they are hating from each other. So we can say the colloidal solution in which there is no affinity between the particles of dispersed phase and the dispersed medium, right? This type of solutions, they are formed by difficulty. They are not easily get formed. Okay, they are only formed by some special methods, right? But these type of colloidal solution, they are also unstable in nature. They are not stable in nature, right? Here these are irreversible in nature. If you want to form them, you need a stabilizer. You have to add a stabilizer in that because here the particles, they get aggregate to form many molecules. So they are able to show the Tyndall effect. They can show the Tyndall effect. As well as these particles, they get easily precipitated on adding small amount of electrolyte. You can coagulate the particles very easily if you will add small amount of electrolyte to them, right?